obligé, j'ai dû m'en aller, partir bifurquer.
One of the most striking benefits we've gained from the relationship with Amazon and working with AWS is our ability now to tap into scale of infrastructure. We're not having to invest in big tin anymore, and that's dramatically reduced our capital expenditure.
So a lot of times when people think of the cloud, they say, well, it's less expensive, it's easier to get up and running. But I think what's more important is that the innovation helps us do things faster, and it makes things practically feasible that were never available to us before.
We chose AWS over other infrastructure providers for two reasons. One is the maturity of the capabilities within their cloud environment. The second is the cost. It's by far the lowest cost infrastructure.
We chose AWS because we wanted the ability to deploy elastically in the cloud and to handle changes and variances in the demand of our application and to handle that when it was needed.
We did a full evaluation of Amazon Web Services and a few other vendors, and we found that Amazon was, in fact, 3 to 4 years ahead of anyone else that we had evaluated.
It would have been very hard for us to scale as quickly without AWS. We've got about 8 billion objects in our S3 buckets and about 410 terabytes at last count of data being stored there.
It's important for us to be able to add thousands of servers and terabytes of storage at minutes' notice. We've actually increased our level of reliability by more than an order of magnitude.
Amazon Web Services to us was really about making a potentially expensive product affordable for us and our customers.
We have definitely saved on the order of millions of dollars by running in the cloud.
We definitely see a continued value in using the cloud because of the flexibility, because of the scalability, and because it allows us to do those things very easily.
What will you run in the AWS cloud? Ladies and gentlemen, please welcome to stage Senior Vice President of Amazon Web Services, Andy Jassy.
Thank you so much for being here for our first ever big developer conference, AWS reInvent. It is absolutely thrilling for us. It's hard for us to believe that we started AWS just 6.5 years ago. It's amazing how quickly it's grown, and it's really awesome to have all of you here to share this first conference with us today. I thought I would give you just 2 quick grounding notes about our conference, since I'm the first speaker at our first ever conference. The first thing is really about what the intent of the conference is. It's really not intended to be a marketing conference. I think when you look at the content that we have, it's going to be substantive content. It will be a lot of the courses and a lot of the breakouts we chose were suggestions from our customers. A lot of our customers are going to be teaching many of these breakout courses. And our intent is for you to learn a lot more about the cloud and to be able to take these strategies and tactics back to your companies to leverage the benefits that so many companies are leveraging today using the cloud. The second thing I thought I would explain is why we chose the name of the conference. And we had a lot of debate internally about what we should choose as a name. And we tried to pick a name that encompassed 2 things that we're seeing happening that are really exciting. The first is just the incredible invention going on of brand new companies from a clean piece of paper inventing businesses and applications from scratch on top of AWS. And then the second phenomenon is how many enterprises and government agencies are reinventing their businesses and reinventing the way they acquire technology and reinventing the speed with which they're able to get new projects done and move their businesses forward. So we tried to pick a name that encompassed both of those, and hence reInvent. So we have over 6,000 people here from 60 countries at reInvent, and then apparently another 12,000 watching the streaming video. And so it's a broad group of people, and we're really appreciative you're here. So I thought today, in my keynote at least, I would talk about a few things. I'd talk a little bit about how the AWS business is doing. Why are customers moving to the cloud and so quickly? What have we been working on the last year? And then how are enterprises using AWS? So I'll start with a quick update about how the AWS business is doing. So we have hundreds of thousands of customers in over 190 countries, and they range from some of the most successful startups like Pinterest and Instagram and Dropbox and Spotify to large enterprises like Netflix and Shell and Samsung and Adobe and Intercontinental Hotel Group and Hitachi, to government agencies and academic institutions. We have over 300 government agencies worldwide using AWS and over 1,500 academic institutions using AWS. So a very large, fast-growing, and diverse customer base. And since the beginning of AWS, our ecosystem partners have been a very strategic and important part of helping customers move to the cloud and are continuing to grow the business. And so they range from systems integrators like Capgemini and Wipro and Cognizant to ISVs like SAP and Oracle and Red Hat and Citrix and Pega and Dassault and Autodesk, a very large and fast-growing ecosystem. And we also, in May of this last year, launched something called AWS Marketplace. And what that is it's a way for third-party software sellers to be able to sell their products to all the AWS customers who come to the AWS site. And in one click, you can deploy those applications on top of AWS, and all that deployment is done behind the scenes for you. And that business for us is growing very quickly, and it's a great opportunity for our ecosystem to continue to get in front of more customers and sell their solutions. So apart from having hundreds of thousands of customers in over 190 countries, I'll give you a few other scale data points for our business. Our storage service, Amazon Simple Storage Service, or S3, is now storing well over 1 trillion objects and pretty regularly runs at over 800,000 requests per second, so very large scale. Our Elastic MapReduce service, which is really Hadoop on top of EC2, has run over 4 million clusters in just under 2 years. So again, that is exponentially growing as well. And then I thought this was an interesting data point. So if you look at Amazon, the retailer, back in the year 2003, Amazon, the retailer, was roughly a $5 billion revenue business with nearly 8,000 employees and obviously a lot of servers because Amazon's a technology company. Today in AWS, every single day, we're adding enough new server capacity to have handled all of Amazon globally when it was a $5 billion business in 2003. So think about that. Every single day now, we're adding enough new servers to have handled a $5 billion global business. So we're adding a lot of data centers and a lot of servers, and it's a pretty incredible operation to make that all work on a daily basis. Our global footprint is continuing to grow at a very fast pace. And the way to think about regions for AWS is it's a physical place in the world where we have infrastructure, where we have multiple data centers, which we call availability zones. And we now have 9 regions all over the world. We have 1 on the East Coast of the United States, 2 on the West Coast of the United States, 1 in Europe, 1 in Singapore, 1 in Tokyo, 1 in Brazil, 1 in Australia, which is our newest region, which we just launched a few weeks ago. And then we have a US government-only cloud that we call GovCloud that we launched about a year ago, which allows for government workloads which have ITAR compliance. And ITAR effectively means you have to be a natural US citizen to operate the hardware or software. And we have a government-only region that we call GovCloud. And then across those 9 regions, we have 25 availability zones and 38 points of presence or edge locations for our content distribution network, which is Amazon CloudFront. When we conceived of AWS, and before we launched the services, we had quite a few animated debates about how we should build the services. And one of those most hotly debated topics was, how many decisions should we make for developers ourselves? How much functionality should we build from the get-go before we knew how they were going to use the services? And how paternal should we be? And what we ultimately decided was that we did not want to be paternal. We wanted to let developers stitch together these infrastructure building blocks however they saw fit. And it was okay if they stubbed their toes a little bit. We thought that the control and the innovation that developers would want would outweigh that risk. And it's turned out to be a really good decision for us and for our customers. For our customers, because they've been able to stitch together and comprise applications from our infrastructure platform and these building blocks in ways that we never imagined and that are incredibly innovative. And for us, it's allowed every imaginable use case to be built and run on top of AWS. And that's what you see today. And it's everything from all kinds of internal and external facing websites and applications, social media apps, games, media distribution, high performance computing and big data analytics workloads, disaster recovery and archive. Literally every imaginable use case is being run in AWS today. One of the most interesting use cases of all of them on AWS is what NASA and the Jet Propulsion Lab, JPL, is doing on top of AWS. It's very interesting. And here to share some detail about what they're doing are the CTO, Tom Soderstrom, and rocket scientist, Khwaja Shams. Guys?
At JPL, we explore the unexplored. We don't always know what we'll find when we land there, so we have to prepare for the unexpected. To do that, we invent or reinvent spacecraft, instruments, in fact, our entire approach to IT. Throughout this conference, we'll talk about our experience with cloud computing. This morning, we'll give you a specific example that we hope you will find exciting. We certainly did. So let's talk about JPL first. We work in the foothills of Southern California, in Pasadena. We work in the cold. It's not actually so cold in Southern California. Sometimes we work in the heat. That's the station fire that got within a few feet of JPL's gates. That's when it's reassuring to know that you have your computing resources somewhere else as well, in the cloud. In fact, our heads have been in the cloud for years. Very big clouds, trillions of miles across. We look at the origination of the universe, what it's made up of, where it's going. We spend a lot of time on that. Other time, we spend looking at Mother Earth. In Earth orbit, trying to understand tsunamis, earthquakes, and global climate change. Yet other times, we spend on Mars. In fact, NASA and JPL has been on the surface of Mars for over 10 years now. And in fact, we have detected water in the form of ice. We have not yet detected life. To do that, we constructed the most ambitious project yet, the Mars Science Laboratory Curiosity Lander. For that to work, we would have to launch a vehicle the size of a Mini Cooper 150 million miles away to a pinpoint precision landing. Let's take a look at what the plans were for that. So pinpoint precision landing means you have to steer yourself through the atmosphere so you don't bounce off and so you get to the right place. You have to slow yourself down. It enters at 1600 degrees, so it has a heat shield. It would open a huge parachute, the biggest one you ever saw, at a neck-snapping 9G. Would drop the heat shield, and now one invention never done before is it would have to free fly itself because it's still going too fast. So if you noticed, it bounced up. So it would first go sideways, not to bump into the lander. So now, as it's steering itself with those thrusters down towards the surface of Mars, there would be too much dust thrown up. So what would we do? Yet a new invention, the sky crane. Essentially a huge fishing line, lowering it gently, we would hope, towards the surface of Mars. landing at a gentle speed like jumping from a 6-foot table. So that's the plan. Once it would land, it would cut the cord, and the lander would fly away and hopefully land somewhere else, not on top of the rover, because that would indeed be a bad day on Mars. So that was the plan. To tell us what happened and a very personal account of how it worked and how we use cloud computing and, in fact, IT, here's my friend and colleague, Khwaja Shams.
Thanks, Tom. Thank you, Tom. I'm going to take us back today to the night of August 5th, 2012, where 150 million miles away, the Curiosity Mars rover is about to enter and complete its journey to the surface of Mars. Engineers at NASA have worked tirelessly for nearly a decade to make this day a possibility. We have executed countless simulations, tested every individual component, but the system as a whole is about to be tested for the first time. We can feel success on the horizon, we can taste the victory, but the smallest mistake can take it all away. Tonight, everything must be perfect. Millions of people are watching us from around the world, relying on us to safely land Curiosity. We have deployed web experiences and video streaming solutions on the cloud to share tonight with the whole world. Tonight, everything must be perfect, and tonight we either succeed remarkably or fail spectacularly. We eagerly look towards the sky with anticipation because we know that it all comes down to the next 7 minutes, the 7 minutes of terror. Having developed the data processing pipeline for Curiosity, tonight is the toughest test of my career. As soon as Curiosity lands, bits will flow through my pipeline to be processed, stored, and then distributed as images to the mission operators and scientists, as well as the rest of the world. My heart is pounding as I steal a glance at the AWS Health Dashboard to ensure that all the services Curiosity relies on today are up and running. EC2, check. S3, check. SWF, check. VPC, ELB, autoscaling, Route 33, SimpleDB, RDS, check. CloudFront, CloudFormation, CloudWatch, check. It's showtime. The world watches with a video streaming solution deployed on the cloud, a solution that could withstand the failure of over a dozen data centers and still deliver the live video stream from JPL to you. A solution that can scale over a terabit per second, but one that only requires us to provision and pay for exactly as much capacity as we need. A solution that is possible today only due to the invention of cloud computing. The excitement builds around the world as Curiosity enters the Martian atmosphere and its temperature rapidly rises to over 1,600 degrees. I take a glance at our CloudWatch console to realize that our streaming solution has gone up to over 40 gigabits per second. I calmly launch into the CloudFormation stack to increase our capacity and register it to the Route 33 domain. Curiosity deploys its parachute at Mach 2, and our streaming solution exceeds 70 gigabits per second. I calmly launch into the CloudFormation stack. Curiosity jettisons its parachute and activates its jetpack as it approaches the surface. Back on Earth, we get a surprising call. The main JPL website, still running on traditional infrastructure, is crumbling under the crushing load of millions of excited users. We act quickly and route all JPL website traffic to the CloudFront-based Mars site. Our traffic exceeds to over 100 gigabits per second, but the cloud hasn't even started to sweat. No. The sweat is only on my forehead as I anxiously await the next bandwidth milestone so I can add more capacity. We are a scant 21 meters from the surface of Mars as Polyphony, our data processing pipeline, provisions EC2 nodes in anticipation of the bits coming to Earth. The Sky Crane lowers the rover down to the surface of Mars. Curiosity has landed on Mars. The whole world celebrates with us, and we are just as thrilled. We have made every JPLer, no, every NASA employee, no, every American proud. We have made humanity proud, for we have landed a 1-ton mobile lab on the surface of Mars. Mission accomplished, or is it? The landing engineers have been successful tonight, but my test has just begun. The bits flow from Curiosity to the Odyssey orbiter to the Deep Space Network and then finally into JPL. An intricate orchestration process coordinated by simple workflow magically causes nodes at JPL to upload these bits onto an S3 bucket. EC2 nodes pick up these bits and process them into images. These elastically provisioned EC2 nodes will process the images rapidly and within seconds of bits arriving to Earth. The first Mars images will be on your iPad, Android, and laptop screens around the world. On August 5th, we had 2 successes. We landed Curiosity on Mars, and we shared the first pictures from Mars with you in real time. You saw the first pictures from Mars at the same time that we did. Mission accomplished. Thank you.
Just as you would use your smartphone to take a self-portrait and send to your family, Curiosity extended its 6-foot arm and took a picture and sent it to its family, all of you. So this is the first self-portrait on Mars by a rover, and it would tell us it's healthy, and it's now looking for signs of past life. On behalf of the JPLers and the NASA employees and everyone else who made this happen, we thank you for listening to our story.
That was awesome. It was very cool. Okay. So I thought I would share some of the main reasons that we're finding why so many customers are moving to the cloud and why they're doing it so quickly. And there are a few benefits that we hear frequently from customers that they would cite as the most important reasons. The first thing is, if you can trade capital expense for variable expense, that's very attractive. Instead of having to lay out all that capital for data centers and servers before you know how you're going to use them, and if you don't have to do that and instead just pay as you consume resource on a variable basis, that's very appealing. And on top of trading capital expense for variable expense, customers love the fact that in the cloud, they get to pay a lower variable expense than they can do on their own. And that's because AWS is able to take its very large scale and pass those on to customers in the form of lower prices. And you can see some customer examples on this slide. Samsung saved over $34 million in moving their Smart Hub application to AWS. One of the largest banks in Australia, the Commonwealth Bank of Australia, saved tens of millions of dollars in the first dozen apps they moved to AWS. And Foursquare is saving 50% on their analytics apps. And then recently, IDC did a study where they looked at 12 companies and looked at their usage of infrastructure on premises versus in AWS, and then did a 5-year TCO analysis and found that they saved 70% if they moved to the cloud. And we have this very interesting virtuous circle going on, which is as we have more customers who use AWS more, it means we have to go buy more infrastructure. But as we buy more infrastructure, we get economies of scale, which lower our infrastructure costs. And as we lower our infrastructure costs, we're able to lower our prices to customers, which drives more customers. So it's a very useful virtuous circle for both customers and for AWS. And then it turns out that you can inject energy into this flywheel. So as we add new services and new features, and as we expand our global footprint, and as we continue to partner with our very large and growing ecosystem so that more companies can run the applications they want to run on AWS, and more companies get help from systems integrators to actually get moving to the cloud, it turns out that we're able to spin that flywheel faster. And as we're able to continue to innovate on our infrastructure, so in our data centers and on our network and with hardware, we're able to get better economies of scale, which lets us lower our infrastructure costs, lower our prices, and again, spin the wheel going faster. And you've seen this bear out as we have lowered prices on 23 different occasions in the last few years, largely in the absence of any competitive pressure to do so. And actually, I have one more price reduction to talk about. I'm excited to tell you guys that we are lowering the price for Amazon Simple Storage Service, Amazon S3, by about 25% across the board. Here you can see, Here you can see the US standard region. This is just an example, but you can see the tiers all going down from about 24 to 28%, and that's true in all the regions, so we're excited to share that news with you today. The third thing that customers tell us that they really like about the cloud is that they don't have to guess on capacity anymore. So any of you that have tried to launch a new project know that you have to guess what your capacity is going to be. And that's actually really hard to do without knowing what the customer response is. And so what happens is you end up making some projection represented by the green dotted line, and the actual usage is often something like the solid white line. And what that means is that in the beginning, you actually are sitting on a lot of wasted capital and resource until your application takes off. And then if it does, you're left with too short capacity. And you either have to decide to provide a bad customer experience, which most people don't choose, or you have to run around like a chicken with your head cut off and find somebody who can get you that infrastructure quickly, and you almost always overpay and overcommit to do it. In the cloud, that problem goes away. You don't have to guess. You provision as much resource as you think you need early on. If it turns out you need more, you seamlessly scale up. If it turns out you don't need as much as you provisioned at one point, you just give it back to us and stop paying. That's a very different model than the last 30 years. The fourth thing customers tell us is that the cloud dramatically improves how quickly they can get to market with whatever applications they're thinking about. In the old world, if you talk to an engineer at an enterprise or a company and you ask them, how long does it take you to provision a server for something new or to put something in Integ? We got answers when we asked customers this that range from 6 to 20 weeks. That's maddening, 6 to 20 weeks for a single server. And what it does is it just stifles innovation. People figure, why bother if it's going to take so long just to get a server? In the cloud, you can provision completely on your own, self-service. You don't have to talk to anybody, hundreds or even thousands of servers in minutes. And that really changes how quickly you can deploy applications. And you can see, News Limited used to have 6 teams taking 56 days to set up a big development environment. It's now 1 team in 3 days. You can see that Lionsgate went from weeks to hours to deploy, and Bampage can double their server capacity now in 20 seconds. And there was a recent IDC study that showed that it's actually 5 times more efficient all in to use the cloud than actually to do it on premises. And I think that's frankly understating it. But any company that does a lot of innovation will tell you that the 2 most important things are, number 1, being able to try a lot of experiments, and number 2, if those experiments don't work, and many of them should not work if you're really pushing the envelope, not to have to live with the collateral damage of a failed experiment. And in the cloud, you can spin up thousands of instances in minutes, so you can try any experiments that you guys as a team come up with, and if they don't work, just give them back to us or use them for other experiments you want to try. Really changes the game and how fast companies can move their businesses forward. The 5th thing we hear from customers is that their scarce resource in most companies is software development engineers. Engineering teams have this long list of priorities and projects that the company wants them to do, and you're left with this unpleasant experience of having to try to prioritize between them. And those or decisions are really specious. They're really hard to make the right ones. We know from the early days of Amazon, it was near impossible. If you can take that scarce resource, who are software development engineers, and instead of having them focus on the infrastructure, which is important, but hardly ever differentiates your business, and instead have them focus on projects that move your mission or your business forward, that's a huge advantage. The 6th thing that we hear from our customers is that they like the fact that they can provide a global, high-quality end-user experience all over the world. So virtually every company now, even startups from day one, given the nature of the internet and the mobile world we live in, have global end users. And so in the old world, people would store their applications or run their applications in one data center or a couple data centers in one geography. And the idea of actually being closer to their global end users seemed like a nice to have, but I don't know how I'm going to do it. I don't know who to rely on. I don't know how to contract with them. I don't speak the language in some cases. It just seems like it's not going to be easy to do, and so most don't. But in the cloud, the game changes. you can have your application in any one of the 9 regions AWS has all over the world, and that means you can provide a lower latency experience for your customers, which is a much better end user customer experience. So in summarizing the benefits, the main benefits of why people are moving so fast to the cloud, it's that they get to change capital expense for variable expense, pay a lower variable expense than they can do on their own. They don't have to guess on capacity. They can move quicker, which enables a lot more innovation. They get to spend their scarce SDE resource on projects that move the business forward, and they can go global with their application presence in minutes. What's interesting is when we launched AWS and the cloud started to get some traction, what we started hearing from old guard technology companies was, there's nothing new here. This is just virtualization. There's nothing new in the cloud. And as customers saw through that and realized that what AWS provides is a combination of software and hardware and data center all wrapped in a service, the old guard technology companies kind of abandoned that line of reasoning. And then they said, okay, fine, the cloud is different. I'll give you that. It's not virtualization. But you can get all the benefits of AWS in a private cloud in your own data center. That's, that was interesting too. And what you started seeing was that these companies started taking all of their existing products and affixing the word cloud to them and said, dun, 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 we have cloud products too. You can do this in your own data center. Have at it. But what the industry started calling this group of people that were attaching the word cloud to all the products and saying we have the cloud too was cloud washers. And you have to be careful about who's telling you what and get into the details of what's being offered. And what's interesting is if you look at the benefits that I just spent a few minutes talking about on why people are moving to the cloud, they actually have nothing to do with the word cloud. They have everything to do with the actual benefits. And then if you go look at the private cloud, they actually have none of the benefits that I just mentioned. You don't get to trade CapEx for variable expense. You pay a high fixed price, not a variable expense. You actually don't get elasticity as a company. You don't get that innovation cycle and that mobility and speed to market. You still have to manage it with your own SDEs, and you can't go global in minutes. And for the few companies so far that have actually implemented a private cloud, you can look at the benefits they were trying to achieve, which, by the way, is a fraction of the benefits I just mentioned on why people are moving to AWS. And you can see the vast majority of them aren't accomplishing the benefits they set out or the objectives they set out to accomplish with a private cloud. So you ask yourself, why are these old guard technology companies so desperately trying to get you to buy the private cloud? Why? And I think the answer is that the economics of what we're doing are extremely disruptive for old guard technology companies. These are companies that have lived on 60 to 80% gross margins for many, many years. And in fact, you can see that they set expectations that that's what they're doing, and this is what they communicate externally. Here are 3 quotes from the senior-most people at some of the largest old guard technology companies, all Fortune 100 companies. So here's the first one. We can achieve these record margins as an integrated hardware and software company because we are focusing on high-margin systems. Another CFO. Once again, margin expansion was the largest contributor to growth. And then a third, who says by 2016, we expect to be growing in line with GDP, with operating profit growing faster than revenue, industry-leading margins, and disciplined capital allocation. These are actual quotes, and these are the businesses that these companies like to run and have run for the last 30 years. And high-margin businesses have been around forever and in lots of industries, and they're obviously a very valid and successful business model. It's just not ours. It is radically different to run a 60 to 80% gross margin business than a high-volume, low-margin business. And if you believe, like we do, that the vast majority of computing is moving to the cloud over the next 10 years, it stands to reason that cloud computing is going to be a high-volume, low-margin business. Now, if you run a high-volume, low-margin business versus a 60 to 80% gross margin business, You think about everything differently. You think about your pricing differently. You think about your cost structure differently. You think about where you spend your innovation cycles differently. If you can take cost out of your own cost structure, whether you pocket those as more profit or give them back to customers in the form of lower prices, you think about that differently. Now, Amazon, every business that we run is a high volume, low margin business. We like those businesses. We're very comfortable running them, and we have that DNA. I think most of the old guard technology companies who are running 60 to 80% gross margin businesses don't like those types of businesses, and it's why they're pushing the private cloud so hard, because it doesn't disrupt their existing business models. But I think even those companies over time will see that the world is moving the direction that AWS is pointing. And then it will be interesting to see how many of those companies will be good at operating high volume, low margin businesses, because you don't flip a switch overnight and become great at operating high volume, low margin businesses. They're completely different operating characteristics. So next up, coming on stage, is a CEO of a company that very easily could have built their own private cloud. They are one of the most qualified and technically competent companies that we work with and have ever seen. But this CEO had a lot of vision about where things were headed in the cloud. And it's my pleasure to introduce the CEO of Netflix, Reed Hastings.
Well, Andy, a 25% price cut. I feel very welcome. Thank you. You saved us a fortune just starting the day off.
Happy to do so. Nice surprise. So thank you for being here with us. Tell me what stage you're at in your cloud evolution.
Well, we started about 4 years ago in 2008. And we recognized that with the advent of streaming, that Netflix computational resources was going to grow rapidly. We didn't really appreciate how rapidly, but very rapidly. And so we started to figure out how to build out our data centers. And about that time, someone sent me Nicholas Carr's book, The Big Switch. And I have to tell you, for me, it was like a Damascus Road experience. When reading that book, and he pointed out that companies like Netflix used to have a VP of electricity. That was a real role. That was an important role because you generated your own electricity. And you know, that's so absurd by our modern standards. It hit me that, wow, this is really happening. And that's when we started working with AWS. We got our first stuff up in late 2009, 2010. And now about 95% of our computation and storage is in AWS. We've got some remaining low volume systems that we haven't yet converted. But we hope by the end of next year to be the largest business in the world that's 100% on AWS outside of Amazon retail.
And what gave you the confidence in 2009 to move to the cloud? You were ahead of your time.
You know, we were ahead of our time, but we were facing some extraordinary growth. So streaming at that point in 2008 was about 1 million hours a month, and now it's over 1 billion hours a month. So we've had this 1,000-fold ramp up in computational resources necessary over just 4 years with the advent basically of broadband networks and streaming. And so, you know, we had to take some risks. You know, doing that kind of build out with your own data centers was going to be challenging. It's worked out great for us. And the key is that now we're on a cost curve and on an architecture that, you know, as all of this room does more with AWS, we benefit by that collective effect that gets you to scale and brings the prices down.
What do you see as the biggest benefits for you, and where do you want to see it continue to evolve?
Well, the biggest benefits are the scale, you know, that you can operate at, which is basically the pool of everybody together, and that gives us both agility, being able to spin up 1,000 instances and down, and it allows us to participate in a cost curve that we couldn't as an individual customer drive. So those are fundamental.
Now, Amazon, the retailer, competes aggressively with Netflix in the video space. What gave you the confidence to move your infrastructure to AWS?
Well, I think both Jeff and you have been very clear that AWS is a great business and should be run independently. And frankly, the more that AWS retail competes with us, then the better symbol we are of it's safe to be on AWS. So the more that we continue to invest in AWS, it becomes symbolic for the rest of your customers of, well, if Netflix can be on AWS, I guess it's safe for everybody else.
Yeah, and I will echo what Reed said, which is, and we've talked about this many times, Netflix is every bit as important a customer to AWS as Amazon the retailer, and that's true for all of our external customers.
Not yet as big as Amazon retail, but
it's a different business, Reed.
There we go.
Where do you see the biggest tech trends? This group knows that you're a real visionary. What do you see as the big tech trends coming up the next number of years?
Well, there's a couple, both on the client side and on the server side. As fundamentally fantastic as AWS is, we're really still in the very primitive first assembly language kind of phase of cloud computing. When you have to pick individual instance types, M1, M2, M3, something's wrong, right? You as a developer shouldn't have to be picking individual instance types. And it reminds me a lot when I first started in computing, and register allocation was the big deal, and how you allocated registers made a huge difference in performance and when you loaded and unloaded them. And then this magical thing, compilers, came along, and the compilers did an awfully good job at register allocation, and then only on occasion would you have to drop into assembly code and do your own register allocation. And so we're kind of at that stage before the compiler, and over the next 5 or 10 years, things will happen to make cloud computing much easier, where you don't have to do things like pick instance types. And in particular, the core underlying next step in the technology is being able to move running live instances. Once you can move running live instances at the virtualization level, then Amazon's automatically can move your jobs around. And VMware does this today with vMotion, and has done this for many years. So it is technically possible, but it's extremely demanding to be able to do that at scale. And so think of that as the next stage on virtualization for all the cloud providers. And then the benefits it brings is you can just say compute, and Amazon will automatically search and find the best type of instance relative to your cost profile. It will also compact instances, so the bisectional bandwidth will be much higher. It allows tremendous efficiency gains. But it's when you think about what's required to move a running instance seamlessly, it's an enormous technical challenge. So we wish you great work on that, and hope for that next wave, which will presumably come over the next couple of years. It's already today, even without that, yeah, we have to pick instance types, but it's a fantastic system. So that's what's happening on the cloud side. On the client side, it's really the rise of touch. These handheld devices, whether they're tablets, whether they're glasses, wearable computing, the level of personal computing that we're going to have is incredible, and then it's all cloud assisted. So Siri is a great example. You talk a little bit, it collects, it does some DSP processing, sends it up, and then it's a big cloud application that tries to match what you're thinking and doing. And as you can see, we need more cloud resources. Okay, that'll make Siri better. If we can go 10x in the cloud resources for voice processing, we can at least double the effective knowledge that's felt and things like that. And that's only one scenario. There's going to be so many scenarios that are basically personal computing, cloud assisted, that'll be very transformative over the next 5 or 10 years. And the work that you guys do to bring down the costs and to make things scale is incredibly powerful for application developers envisioning these new scenarios for end users.
Tell me, with access to massive numbers of inexpensive servers, how are you going to use that to improve the Netflix member experience?
Well, for Netflix, the overriding challenge is you've got a little window on a screen, 10 inches. And if you look in there, there's over 10,000 movies and TV shows. So you're looking around at 10,000 things, and it's awfully hard to find what's the thing that's going to be exciting for you right now. And so think of the Netflix challenge as a big ranking problem. What we put in the first 2 home screens dominate what people end up watching. And if we put the right stuff, then people are really happy. And if we put the wrong stuff, then they go turn on cable. And so it's a big ranking problem, like Google search or many of these problems. And the more computational resources we can put into that, the better job we can do. And so we derive a new input, like if we look at time of day or if we look at zip code and we add that as an input, we found we can actually do like 3% better, that it's a better system. But to do that, we have to spin up these large experiments. And so there, the agility and the low cost are tremendous benefits to our learning curve of the fundamental ranking problem.
That makes sense. Last question. We have a number of entrepreneurs and CEOs that are here or watching, and you've been one of the most successful of our era. What advice would you give them?
I always just go for what's exciting. I've never been someone who set out to go to business school. I was in engineering school, and then it was exciting to build product. And fortunately, those products have been very successful. But for me, I think different people succeed in different ways, depending on your particular background. But for me, it's just always been this passion for doing great product, and then you build a business around it so you can keep going. But the passion is, when you watch something great, it's just amazing. And I think one that you will like a lot on Netflix coming is House of Cards with Kevin Spacey. That's coming February 1st, debuting on Netflix. So that'll be my content recommendation for you.
All right, I'll take it. Well, as always, it's fun to talk to you, albeit in front of 20,000 people this time. But you're a great partner and really a visionary, and I appreciate it.
And thank you again for the price cut.
You're welcome. Thanks. Great job, Reed. Thank you, Reed. So what have we been working on for the last year at AWS? It's a lot. So we continue to innovate and to deliver for customers at a very fast clip. If you look in 2010, we delivered over 60 significant features and services. In 2011, that number was a little bit over 80. And in 2012, we expect that number to end the year at 158 significant services and features. And the chart behind you, each dot represents a day during the year where we launch at least one new feature or service. So we've been pretty busy, and we have a pretty busy last month ahead of us as well. And what we're trying to do, and the reason that we're trying to continue to iterate so quickly on the technology infrastructure platform we've built, is that we want to enable every imaginable use case and workload that you want to run to be able to work successfully in AWS. And that ranges from brand new businesses building their businesses from scratch on top of AWS, to enterprises having new projects or ideas that are going to change or move their business forward, being able to start those from scratch on top of AWS, to enterprises being able to migrate their applications. Some are easy to migrate, others take more work to migrate and have a 12 to 36-month migration plan. But we believe that all of these workloads are capable of running successfully on AWS and will in the cloud over the coming years. And that's very much informed the way that we've built our technology platform. I mentioned earlier about our global infrastructure. We have 9 regions around the world, 25 availability zones, and 38 edge presences. On the networking side, we have a few offerings that customers find very useful. We have something called Amazon Virtual Private Cloud, or VPC, which effectively allows you to cordon off a section of the AWS network and provision resources into that VPC. And they can be accessed through IP addresses that customers bring to bear or through the internet. You get to set those rules. And then you can connect it via VPN to your own data center, so it almost becomes an extension of your existing data center topography. We also have something called AWS Direct Connect, where we keep adding cities that you can find it, which is effectively a private connection or pipe from your data center direct into AWS. And you can see the various cities that we've added during the year. And then we have a DNS service called Amazon Route 53. On the compute side, we have Amazon Elastic Compute Cloud, which many of the people in this room know about, and we were just talking about. We continue to iterate very quickly on the features there. We've recently added High I/O instance family, as well as a brand new next generation standard instance family. And then we added a reserved marketplace this year, a reserved instance marketplace, where customers who have reserved instances and either want to trade to a different region or availability zone or just don't need them anymore can sell them to third parties. We've got an auto-scaling capability which allows you to set triggers on when you want to automatically scale up or scale down your instances. And then we have a load balancing service called Amazon Elastic Load Balancing. On the storage side, we have a very large object store I talked about earlier, Amazon S3. We have a persistent block store that works with EC2 called Elastic Block Store, or EBS. We have a storage gateway that we added this year, which is effectively a virtual appliance that sits on premise and asynchronously backs up your data to the cloud. And then our newest storage service, which is Amazon Glacier, which is very cost-effective storage for archival and backup, 1 cent per gigabyte per month, which customers are using in very large amounts right now. We have a number of database services. So we have a relational database service that we call Amazon RDS, which started with a MySQL edition, and then we've added Oracle and SQL Server editions, the latest coming in the middle of this year. And then we have a very scalable, fast, high throughput, NoSQL non-relational database service called Amazon DynamoDB. It's single-digit millisecond get and put latencies. It's the fastest growing service in the history of AWS. We launched it in January of this year. And then we also have a caching service that we call Amazon Elasticache. We have a number of application services. We have a content distribution network called CloudFront. We have a big data analytics service called Amazon Elastic MapReduce, which is really Hadoop on top of EC2. We have a search service. We have a queuing service. We have a notification service. We have a workflow service. We have an email service. It's a very broad, very robust set of functionality. And our ecosystem partners continue to add functionality in the application services space to make it easier to run your workloads. And they range from security services to logging services to developer and telephony services to business intelligence services and test services. Very vibrant ecosystem. And then we have a number of deployment and automation options for you. So we have a monitoring service called CloudWatch, and then we have fine-grained access control and user management that we call AWS IAM, or Identity and Access Management. And then 3 different ways you can deploy your resources and manage them. We have a web GUI, which is our AWS Management Console. We have really recipes or templates that you can use, either create your own or use ours, called CloudFormation. Or we have a drop-in container that allows you to upload a file. We spin up the instances, set up the load balancing, set up the auto-scaling, set up the monitoring for you, and you just get to run your application from there. It's called AWS Elastic Beanstalk. We started last year with Java. This year we've added PHP and Python and .NET and Ruby, and lots of customers are using these options as well. So we get asked a lot, so what's the next AWS service going to be? And I'm excited to tell you what that next AWS service is going to be. And it's a space that we were asked by our customers to look at, and that is a really interesting space, which is around the data warehousing space. So anybody that has used a traditional old guard data warehouse solution knows that it's really expensive and really complicated to manage. And you can see on that piece of paper attached to the slide how many things you have to go figure out and pay for. And you have to get licenses, and you have to multiply by the number of licenses you need and by the number of cores you need. It gets expensive quick. And as this Gartner fact points out, on average, enterprises have 3 to 4 DBAs that they have to hire for each data warehouse that they have. And customers are unhappy with these solutions. They've been telling us now for a couple years. The large companies feel like they're paying way too much, and it's a pain in the butt to manage. And smaller companies who know that it's never before been less expensive or easier to collect, store, and analyze data than today because of the cloud, they're really left out in the cold. They can't afford these data warehousing solutions. And as a result, they throw out a lot of their data. And so our customers have asked us over the last couple of years to think about this. And what we did was we thought, well, what would a data warehousing service look like if we did it the AWS way? Well, It would have to be really easy to get started and be self-service and be able to scale up massively. We wouldn't want anyone to have to pay up front if they didn't want to. They could use it as they saw fit. It had to be really fast, and it had to be inexpensive. And then it needed to be open and flexible and work with the BI tools that people are used to using. And that is what we decided to build. And so it's my pleasure to introduce the preview that we're announcing today called Amazon Redshift, which is our new data warehouse service. And what it allows you to do is to easily and rapidly analyze petabytes of data. It's about 1/10 of the cost of traditional data warehouse solutions. It automates the deployment and the administration for you, so you don't have to worry about that. And it works with the popular business intelligence tools. And you can choose from either 16 terabyte nodes or 2 terabyte nodes. You can configure up to 100 nodes and up to 1.6 petabytes. The data is stored in columnar format, which means that the I/O moves much more quickly, and your queries on your data will be much faster than typical. And then you can query with the typical standard SQL and JDBC and OBDC. Now, Amazon's retail business has a pretty big data warehouse. It's an old guard data warehousing solution. And we've been working with them for several months with their testing and using Amazon Redshift. And so their data, if you look at their data warehouse, it's got 32 nodes. It's 4.2 terabytes of RAM. It's 1.6 petabytes of disk. And we spend several $1 million a year for it. And so they did a test. And they basically took 2 billion rows of data and 6 of their most complex queries, and they ran it on Redshift versus their old world data warehousing solution they've been using the last several years. And on 2 16 terabyte nodes on Redshift, for $3.65 an hour, roughly the cost of a latte, which we drink a lot of in Seattle, and $32,000 a year, they were able to achieve on all those queries at least 10 times faster performance. So instead of spending many millions of dollars for Redshift, they spend $32,000 a year and end up with 10 times faster queries. It's pretty game-changing. As we mentioned, it will work with all the popular BI tools right from the get-go to work with MicroStrategy and JasperSoft and SAP Business Objects and Cognos. And the pricing will start at 85 cents an hour on demand if you want to just pay as you go. If you make a 3-year reserved instance reservation, it ends up being less than 23 cents an hour. And what that means is that if you look at the typical cost of these data warehouses, this is a commission on the left that IBM commissioned themselves to compare the cost of data warehouses, including their own. Typically, companies pay between $19,000 and $25,000 per terabyte per year for their data warehouse solution. For Redshift, if you buy the reserved instance type, it's less than $1,000 per terabyte per year. Huge difference. As I mentioned, the limited preview starts today. You can see the URL where you can sign up and get started, and then we expect the full launch to come in early 2013. And we're excited about it too, thanks. So how are enterprises using AWS? The number one question we get from enterprises, which I think is a pretty understandable number one question, is how about security? Is the cloud secure enough for my apps and my data? And in AWS, security is our number one priority. We will drop anything we're working on if we think there needs to be work done to fortify security further. But we use all the same security strategies and techniques that have been used for the last 30 years by traditional enterprises. We have very strict physical access control to our data centers. We watch the network to make sure there's no packet intrusion. We're very careful to wipe our hardware clean when customers abdicate that hardware for their resources. And then we have application level services that help you with security, like identity and access management, where you can set up a parent account and users underneath it with unique credentials. And then for each of those users, you can set up what rights they have to each piece of data, and you can change that at any point. And our customers have told us a number of times that to move more of their workloads comfortably into AWS, they need some of the standard certifications that they're used to having in their data centers. And that's why, over the last few years, we've gotten certifications for SOC 1 and SOC 2, basically the old SAS 70, ISO 27001, PCI compliance, HIPAA compliance, the Motion Picture Association certification, which is a big deal in the entertainment industry, and then a number of government certifications, FISMA Low and FISMA Moderate, DICAP, and then, as I mentioned earlier, our GovCloud, which has ITAR compliance in it. And what we find when we talk to people who dig deeply into the security of AWS is they come away impressed, but they also often find that they feel like their security posture improves when they move to the cloud. And I think there are a couple reasons for that. I think number one, because of AWS's size and because of what we do, we have a very large and expert security team, much larger than what most companies can have on their own. And we provide some visibility that's hard to have at companies. So CIOs will also often talk about the canonical server under the desk problem, where they know some of the servers are outstanding. They don't really know where they all are. They know some are under developers' desks. That makes them a little bit uncomfortable. In the cloud, you make a single API call, and you know where all of your servers are instantly and who's checked them out. So it's better visibility that way. And the other thing that our customers are finding is because AWS has so many customers across so many countries and every business segment you could imagine, we're constantly getting feedback and input from the community on what they want us to do with regard to security, what additional features they want, what visibility they want. So our customers get to enjoy all of the community's feedback. They get all of those improvements in the platform for free. So instead of being in a frozen situation where it's just the constraints of who you can hire to do the work in your own premises and just the ideas you have in your own company, you get the benefit of this large community and then all the changes we're making constantly for free. So one of the very interesting enterprises that's doing really interesting work is NASDAQ. And NASDAQ just recently released a product that's a first of its kind called FinCloud on top of AWS. And it's a financial services cloud for financial services companies to manage their data. And so to tell you more about it and tell you why he ended up choosing AWS to build that new offering on top of, I'd like to introduce the SVP, the Global Head of Access Services at NASDAQ, Ted Myerson.
Hello. Thanks, Andy. Thanks for having me. It's exciting to be here. And thanks to AWS for hosting this amazing reInvent conference. I'm Ted Myerson, Global Head of Access Services at NASDAQ OMX. Now at NASDAQ, we've been providing technology to the financial services industry for over 40 years. We power over 70 exchanges across 50 countries. We also provide technology to over 2,500 broker-dealers and 11 regulators across the entire trading life cycle. That boils down to processing 1 out of every 10 transactions in the securities industry. NASDAQ OMX is where innovation meets action. And at NASDAQ, we've been spending a lot of time looking at the cloud and the paradigm shift for the financial services industry. And I'd like to share with you 4 key business drivers in the financial services industry relating to the cloud. Now, what's happening in this industry is that, taking the term from this reInvent conference, the financial services industry needs to reinvent itself. What's happening is there's extreme revenue challenges. Costs have gone up, revenues dropped. They need to reduce their operating costs immediately. They need to be doing more for less. They have extreme pressure and challenges for top-line revenue growth. And on top of this, with regards to data in the financial services space, every aspect of the trading lifecycle basically needs to be captured, stored, recorded. And that also relates to statements and confirms and emails, all this information. It's only growing in nature. That's a problem. It's a problem when the revenue that you're receiving from your customers is decreasing. Again, they need to be doing more for less. Now, on top of this growing data, the frequency of this information needs to be provided to the regulators faster and sooner than they've ever done before, providing further challenges to this legacy infrastructure that financial services pretty much is based and built on. Now, on top of this, to add further layer of the challenges, there's ongoing new regulatory initiatives. And to put further strain to the financial services industry, the industry needs to constantly retool and rework their legacy systems to accommodate these changes. The cost of compliance is just skyrocketing. And frankly, all these firms need to be doing the same very tasks every day under this regulated environment, not adding a lot of differentiation, uniqueness, and value to their business or even to their customers. So what's the bottom line in the financial services industry? They need to remove cost out of the equation. They need to be able to focus on what they can do best, innovate and provide value to their end customers, differentiate, and find new sources of revenue opportunity. And frankly, that's actually because of AWS why we're all here today. AWS enables us to do this very task, focus on what we do best. And that's why at NASDAQ, we've launched FinCloud, powered by AWS. And for those of you in the back of the room that think that there's a misspelling of a Q in cloud, there's not. NASDAQ's most recognized index, the NASDAQ 100, which Amazon is a proud participant of, the ticker symbol is the QQQ. So we thought we'd add cloud with a twist, so it's cloud with a Q, FinCloud with a Q, and I bet you now never forget that. Now, the financial services industry, when it comes to security, is critical and paramount, as Andy shared. And in security, what we've been able to do is leverage AWS's industry-leading and top-notch security environment. And what we've done for FinCloud is NASDAQ's added above and beyond a layer of encryption and decryption that's tightly integrated and coupled within FinCloud for a seamless end user experience. The second component of FinCloud is it's industry only. And why industry only is important is we've architected and designed FinCloud to meet the financial services needs around this regulated environment. It's not just for customers of NASDAQ, it's for the entire industry. It's a community cloud. The third component that we bring in FinCloud is we aid in compliance. As I shared, NASDAQ has over 40 years of technology experience working with regulators around the globe, that we add this value and economies of scale to the customer base. Again, the industry is doing very similar tasks, and we can take that out of the equation, and we can add domain experience and expertise to this offering for them. So lastly, they can focus on what they do best, focus on innovating, focus on finding new sources of revenue that uniquely differentiate them. And so we've been able to marry the challenges around the industry moving costs out of the equation while being able to innovate at the same time. And frankly, what's been absolutely amazing is that many prospects and early customers have shared with us. So now that FinCloud has solved the regulatory aspect of the requirements for data storage reporting, they now recognize the power and ask, how can I put my entire business inside of FinCloud? It's amazing. Frankly, it's absolutely incredible because you see that paradigm shift happening where they can take this legacy infrastructure that they have and they're able to leapfrog from where they are to where they want to go and build and innovate inside of the cloud. Now, all of you by now are probably asking yourself, why AWS? If NASDAQ has all these years of experience in building technology, why AWS? Well, it's actually very simple. Because AWS has the proven experience. AWS already services customers, large customers around the globe. And that experience isn't just from the customers, but it's also their staff. And for those of the AWS staff who are in the audience, thank you. They're incredible. The knowledge and depth of experience is just amazing. 2, security. AWS security is top-notch. 3, cost efficiency and scalability. Many of the financial services customers have petabytes of data that they need to be able to move. And last, time to market. They need this now. They need to move this now. They need to be able to focus on their business. They need to be able to look at finding these new ways of revenue. And that's where we're able to marry that operational cost reduction with the innovative services, and that's FinCloud. And for those in the audience, for those ISVs that may have questions around FinCloud, we welcome you to please ask us and reach out to us. For those ISVs that may have tools or solutions, analytics, big data applications, services that you may be able to apply to the financial services industry, we welcome you to reach out. We welcome you to leverage the FinCloud distribution channel. And frankly, that's why we're all here today. What AWS has created is this wonderful community. We want to hear from you. We welcome that. So thank you. Thanks for having me. Thanks for letting me share about the exciting FinCloud offering. And enjoy the rest of this amazing reInvent conference.
Thanks, Ted. That was great. So, the second question that we often get asked by enterprises is, how does this, I buy the cloud, I believe the cloud has a lot of value, I want to get started, but how does it actually work with the tools I've been using for a long time? And this slide, as you see, we don't quite understand what the hybrid cloud is. A lot of people talk about it, but it's a little bit of a mystery what it really is. But what we actually do see is that enterprise customers are very interested in a hybrid architecture. And that's what AWS is spending its time trying to help enterprises do. And the situation you have is that a lot of enterprises have a lot of applications, legacy applications they've been running on premises for a long time. Some of those applications are really easy to move, and some of those are a lot harder to move and are going to take time. And so what enterprises want is they want private connections between their on-premises and AWS. They want to make it easy to move workloads back and forth between those two environments. They want to be able to have access control for their identity. They want to be able to have access control and identity integration for what they've already built. And then they want to work with the existing management tools they've been using for a long time. And that's informed what AWS has built over the last couple of years to help enterprises with this transition, which is we've made it easy now for enterprises to integrate with Active Directory with AWS, with our user management and our IAM. We've been working with partners like VMware so that companies who've invested a lot of time and energy in their VM images can move them to AWS and move them back, and that migration is very helpful in saving time. And then I mentioned earlier a few of the networking options for customers that range from Amazon VPC to Direct Connect. And then also, our ecosystem is continuing to extend that as well. And you see us working very closely with a number of these companies you see on the slide, but companies like BMC and VMware and CA are trying to make it easy for enterprises to have a single pane of glass to manage whatever they're running on premises or in the cloud, and to help them make that transition as everything is moving to the cloud. As I mentioned earlier, we have a large number of enterprise applications running in AWS. One of the earliest enterprise application providers that contacted AWS and saw where the cloud was headed, they contacted us about 5 years ago. They were one of the first, and they really wanted to figure out how they could take advantage of this trend they saw coming. These guys have been visionaries, even though they don't get credit for it sometimes. And it's my privilege and pleasure to introduce to you President and Corporate Officer at SAP, Sanjay Poonen.
Thank you very much. Andy and I were, any good partnership starts with a friendship, and Andy and I were classmates at Harvard Business School. I'm not sure 15 years ago, when we were friends and classmates, we were thinking that cloud computing was going to change the world, but we both had a strong passion for technology and innovation. And out of that friendship, I called him a couple of years ago and said, we ought to be partnering together. Many of you probably know our brand. SAP is the largest company in business applications and business software. We run about 60% of the world's GDP runs through our systems. We've expanded now to be the world's leader in analytics, and big data, mobility, and so on and so forth. And as we saw Amazon, not just a great brand in retail, but also now a big brand in cloud computing, infrastructure as a service, we felt this was a very practical way by which we could help our customers lower their cost as we also, as a company, embraced cloud computing. And for many of you, you know our brand as being the leader in the on-premise world. So if anything, our embrace of cloud computing has been so dramatic that it's changed the way in which we are viewing initiatives like big data, analytics, mobile, all moving to the cloud. We have made this something that's comprehensive across the entire suite of SAP. It started off, actually, quite frankly, as we moved into analytics, we were starting to find a number of our customers using business objects in the cloud. In fact, one of the government use cases, recovery.gov, where any of you could go to that site and see where government spending of the recovery funds, the TARP initiatives, you can go state by state, and the business objects tools were being used then. We had a number of companies starting to do that. And that led us to say, we're going to do this all the way for our entire suite. And for many of you, if you think about manufacturing, financials, HR, some of the most complex parts or sophisticated parts of software, if we can get that running in the Amazon cloud, which is what we did next. And that was also driven by customers. Andy talked about Lionsgate. I like that example because when we talked to that CIO, she said, as they are situated in LA, you run out of physical real estate to build more and more of a data center. So they were necessitated to move their infrastructure to the Amazon cloud. Started off first with elements around financials, and now they're looking to move big parts of their ERP. And we've now happy to certify and announce that ERP of SAP will also be available in Amazon. But then we move beyond that to big data and real-time analytics with our pioneering offering, HANA, that's revolutionizing the world of big data and real-time analytics. We now, just a few weeks ago, announced that HANA is available. HANA 1 is available in the cloud, and just in those few weeks, we've had 1,000 customers, 2,000 instances, I think 200,000 hours. It started off with just a few, and now I think there's up to 15 developers. We've embraced now a number of startups. There's one here, Fan Apps, that's doing some beautiful social work, social analytics kind of things on the Amazon cloud. We've also now embraced mobility, and we see that as a big opportunity to manage significant parts of the world's mobile devices. And I'll talk more about that in a second in our partnership with Capgemini. So as you think about this, the big opportunity for you, if you're an enterprise customer, is to think about that infrastructure, whether it's the business suite, financials, HR, that you may be using on-premise. And while we may have a public cloud offering, you may want to take your on-premise offering, move it to the cloud, any shape, any size, and lower your cost of ownership. We've done the same now with HANA 1, which is very exciting. 99 cents per hour, you can get started. For a developer edition, the license is completely free. We want to get every one of you, 5,000, 6,000 of you here, and the potentially tens of thousands of you watching on HANA 1. And then the business edition is 99 cents per hour plus the Amazon hosting fee. We're also putting a lot of focus on startups. We have announced a fund where if you're building on HANA and mobile, we're going to invest behind you. We've had 100 now plus who've joined the program, and many of them are also starting to now put their instances on HANA 1 and AWS. We're excited about a three-way partnership that we announced also this week with Capgemini. There's a test drive location for you to take HANA and mobility. And if you think about something like mobility, we think that there's going to be eventually at least 1 billion devices in the world of companies that need to be managed for things like mobile security, mobile device management, mobile app management. And we're going to do that in the Amazon cloud. We announced that offer with Capgemini. You can get started. It's a very affordable price. And the point is, if it's just 1 billion devices in the world, eventually there are going to be 50 billion things as we think of the Internet of Things, and your refrigerator, your car, your thermostat, all of that start appearing on the Internet. That infrastructure being managed in something like this cloud computing is where we believe the future is. So just in closing, we also are happy to announce a contest. SAP is going to have a HANA One contest. If you can build your best apps there, we're going to screen the best 100 apps and offer more time on Amazon Web Services at our expense, and also a cash prize for the best winning app. So go to that location, contest.saphana.com. We're personally very excited about the AWS SAP partnership. It brings together great brands in business software and cloud computing, and represents the type of customer choice we want to provide to help lower the cost of ownership. So thank you, Andy, for having us here, and I wish all of you a great conference. Thank you very much.
Thanks, Sanjay. Okay. So in this closing segment, I thought I would just share a few thoughts and an example. When we launched AWS 6.5 years ago, developers were really excited and started using the services immediately in large numbers. However, lots of people in the industry looked at it and said, well, it's kind of interesting, but I don't think anybody's going to ever use it for anything real. And then you started seeing people building real applications, and folks said, well, that's interesting, but nobody's going to ever build a business on it. And then you started seeing startups building their businesses all in from scratch on top of AWS. And people said, well, that's nice, but enterprises will never use AWS. And then you started seeing enterprises using AWS, and people said, well, never for mission-critical applications. And now, as enterprises are using AWS for mission-critical applications, the question isn't if anymore. It's really just how fast it's going to move and which ones are going to move first. And what's interesting is that now, as you look at the biggest events in the world over the last couple of years, a lot of them are being run on top of AWS. And whether it's the Super Bowl, where we have customers live streaming the game, or companies like Shazam that's doing real-time advertising promotions with mobile apps, or whether it's the Olympics, where we had network providers run games that were being telecasted at the Olympics on top of AWS, or whether it's reality shows like Dancing with the Stars, who run their real-time voting on AWS, and a number of reality shows actually do the same thing. The Mars rover Curiosity, you heard Tom and Kawaja talk about earlier, which was completely streamed and shown to the world on top of AWS. Or even our most recent political elections in this country, where many of the major news sites used AWS on election day to handle the volume and the complexity of their election day coverage. And it leads me to my last example, which is the Obama campaign. So what the Obama campaign did with their ground game in this last election was pretty unbelievable. And a lot of people credit that ground game with being one of the differentiators in why they won the election. And it's really interesting what happens in political campaigns, because about 18 months before election day, there's hardly anybody who's working on the campaign in a full-time way. But by the time you get close to election day, it's millions of people, and sometimes tens of millions of people when you count all the volunteers all over the country. And so what the Obama campaign did was they built a pretty complex set of applications completely on AWS. They built an analytics database of all eligible US voters. They had a donation collection site and a call center app. They had a supporter engagement platform that they built that made it easy to get to different volunteers all over the country and instruct them where they want them to go. They ran BarackObama.com website on top of AWS, and they had in all about 200 applications. And you can see on these three screens, this is not a duplicate that you can see one of each on the three screens. This is the architecture across the applications that they ran on AWS, over 200 of them. Pretty complicated and pretty elaborate. They used technology in a way that really was never before done with a political campaign. And what you see is that on election day, look at what they did. They were running over 200 apps. They had 7,000 concurrent call center users on their distributed call center app who made over 1 million phone calls just on election day. They had this 27 terabyte voter analytics database that told them who they needed to contact all around the country and who they wanted them to call or knock on doors to get them to vote, with 500,000 transactions per second. It's just incredible. And that really does redefine mission critical, what they did on election day, and I think it was one of the several reasons why they ultimately won the election. So with that, I'll thank you all for listening. I thank you for being here at our first developer conference. We're really excited to have you here, and we hope you have a great conference and learn a lot. Thanks again.
Ladies and gentlemen, this concludes today's program. Please rejoin us tomorrow for keynotes at 8:30 a.m. and 1:30 p.m.
Ladies and gentlemen, all sessions will begin on time at 10:30 upstairs. Thank you.